In this video, we will describe the formation of resting potential. Resting potential is the membrane potential of an axon when there is no transmission of impulse. At resting potential, the membrane of the axon is said to be polar, whereby the inside of the axon is more negative compared to the outside of the axon. This means that the inside of the axon will have lower concentration of positive charge compared to the outside of the axon. The recorded voltage of the membrane potential for resting potential is minus 70 millivolt. So, how is this value of membrane potential is established that we call resting potential? We know that the membrane potential refers to the difference in the electrical charges across the membrane due to the different concentration of positively charged ions between the inside and the outside of the axon. At resting potential, the inside of the axon have higher concentration of potassium ion and lower concentration of sodium ions, while on the outside of the axon there is higher concentration of sodium ion and lower concentration of potassium ion. If we total up all the positive charges from the potassium and sodium ions and compare between the outside and the inside of the axon, the outside of the axon will have higher concentration of positively charged ions compared to the inside of the axon. This is why at resting potential, the outside of the axon is more positive while the inside of the axon is less positive or more negative. Next, why does the inside of the axon has higher concentration of potassium ion while the outside of the axon has higher concentration of sodium ions? This is due to presence of sodium-potassium pump, which pumps 2 potassium ions into the axon and 3 sodium ions out of the axon by active transport. Thus, accumulates high concentration of sodium ions on the outside and high concentration of potassium ions on the inside of the axon. The activity of the sodium-potassium pump will create concentration gradient for each of the ions across the axon membrane. At this point, we have seen why at resting potential, the inside of the axon will be more negative while the outside of the axon will be more positive, as well as why the inside of the axon have higher concentration of potassium ion but the outside of the axon have higher concentration of sodium ions. Now we will discuss the reason for the membrane potential value of resting potential is at minus 70 millivolt. The answer is because the membrane of the axon is more permeable to potassium ion compared to sodium ion. There are more potassium ion channel compared to sodium ion channel on the axon membrane, resulting in more potassium ion diffuse out of the axon down concentration gradient and less sodium ion diffusing into the axon down concentration gradient. It was the combination of sodium-potassium pump activity and the permeability of the axon membrane towards potassium ion that resulted in the outside of the axon having more positive charge compared to the inside of the axon. Next, the amount of positive charges move across the membrane into or out of the axon creates the measured voltage of minus 70 millivolt that we call resting potential value. That's it for resting potential and how it is established.